Hi, this is Group Leader. I'm Jade.
I'm Kirsten.
I'm Destiny.
I'm Ariel. I'm Taraya.
An event happens in cell A such that neurotransmitters are released into the synapse of cell B. At this point, one of four things can happen to the neurotransmitter molecules. They can dissipate into interstitial fluid, reuptake can occur, and they can get taken back to cell A. They can be metabolized by enzymes that exist in interstitial fluid, or they can bind to the receptor located on the presynaptic membrane, postsynaptic membrane, that is located on the dendrite of cell B. Presynaptic vesicles bind to the presynaptic membrane. The neurotransmitter molecules then travel across the synapse and bind in key lock fashion to a binding site on receptors in the postsynaptic membrane located in the dendrite of cell B. The outside of the cell is composed of interstitial fluid, and the inside of the cell is composed of cytoplasm. The postsynaptic membrane in between the cytoplasm and the interstitial fluid is made of a lipid bilayer. Most times the receptor is closed because there is no neurotransmitter bound to it. In this case of the neurotransmitter molecule binding to the receptor opens. This particular transmitter is permeable to sodium.
Sodium enters the cell because of two forces: osmotic osmosis, particles in the solution going down their concentration gradient, and electrostatic pressure. Sodium enters the cell via osmosis because as osmosis, particles in the solution go down the concentration gradient. And because the inside of the cell is negative, with sodium being a positive charge, opposites attract each other, leaving sodium entering the cell. The schematic representation of the cell represents the inside, which is here, and the outside, which is here.
The cell registers a negative 75 millivolts at rest on the oscilloscope. If the receptor binds, the receptor opens, and sodium enters. A rise will happen on the oscilloscope called EPSP, which is this little bump here. EPSP registers the depolarization of the cell due to the entrance of sodium. EPSPs are created when ionotropic receptors located on the dendrites of cell B, the dendrites are open due to the presence of the neurotransmitter binding. When there are a lot of neurotransmitter molecules, summation of EPSP occurs, then adding more positivity into the cell and add to reach the threshold of excitation. This process is known as temporal summation and initiates action potential.
Spatial summation, which initiates an action potential, the location of receptors that cause the threshold of excitation is located not on the dendritic arborization, but at the axon HELOC, which collects the summation of consummation of small electron of repulsion electrical potentials. They add together an axon HELOC at the point of voltage-gated channels. This process generates initiated action potentials from rest because of summation from multiple ESPSs reaching excitation. Then drastic amounts of sodium are entering the cell, causing it to reach 55 from negative 65. This process brings sodium to equilibrium, which then leads for the potassium gates to open since cell is positive because potassium is greater inside the cell. and the positive charges repel each other, leaving potassium going out of the cell.
Once potassium leaves the cell, there is demoralization with sodium entering the cell. Which then causes high polarization with potassium leaving the cell.
The action potential follows a law called the all or no response, where it starts at the axon hillock, reaching the edge of the myelin shaft, where it travels to node. At each node, there is a potassium and sodium graded channel, allowing sodium to enter and potassium to exit, causing action potential to occur. Moving from node to node is called saltatory conduction, a process in which an action potential travels down the axon shaft. When the action potential reaches the terminal button, it interacts with calcium, and the vessels interact with the presynaptic membrane. They slowly open in the process of exocytosis. The molecules of the neurotransmitters are put into the synapse of cell B and cell C.